Okay, so the second part of this question is asking us to identify the conjugate acid-base pairs for the equations we wrote in part A. Okay, so I've still got my equations. Now I need to think about my conjugate acid-base pairs. Okay, so a little recap. We know that these base pairs differ by a H+. So I think the easiest thing to do, conjugate pairs, okay. The easiest thing to do is look at your formula and just look at which species, so this is a species, that's a species, etc., differ by one H+. So we can see that this and that, they differ by H+, and this and this, they differ by one proton also. So then we just have to decide, all right, which one's acting as the base, which one's acting as the acid, and we always write the acid first when we list our conjugate pairs. All right, so we know these are a pair, but which one is the acid and which one's the base? So looking at this species, what's it done in this reaction? Well, it's actually donated a proton, hasn't it? Okay, so it's being transformed from this species to this species by donating a proton. And what kind of molecules donate protons? Well, acids do. Okay, so this is acting as an acid. So that's my acid, and therefore its conjugate base is this species here. Okay. All right, so we've got our two species here, which are pairs, and we just need to decide which one's the acid, which one's the base. So what's this acting as, this water? So it's actually accepted a proton, hasn't it? If we're reading it in this direction, it's accepted a proton, therefore this is acting as a base. So I'm going to list that second, and therefore this is its conjugate acid here. Okay. All right, so then let's have a look at the second one. We can see that obviously it's the same. This is differing by one proton, and these are as well. So, okay, H2PO4 minus, this has donated a proton, so that's my acid. That's acting as an acid, and its conjugate base is this species here, and these two molecules are exactly the same, so this water has actually accepted a proton, so it's acting as a base. Okay, therefore its conjugate acid is the hydronium ion there. And finally, okay, we know that this and that differ by a proton, and so do these. Okay, so this is actually, this is acting as an acid here. If I look at this reaction, so HPO4 2 negative, and its conjugate base is that molecule there, and that is the same for those. So that is about it. These are conjugate pairs. Okay, this is the acid, this is the base. Now, this acid, its conjugate base is this species here. For this base, its conjugate acid is that species there.